Let's review the product rule of derivative, which states that if we have a function f of x given as multiples, a product of two other functions, g of x and h of x, the function's derivative f prime of x, this is the derivative, will be, first we need to find the derivative of this, which is going to be g prime of x, and then we keep this unchanged, multiplied by h of x, plus then we need to find the derivative of this, which is going to be h prime of x, and then we multiply it by g of x. Here's an example. Let's say function f of x is given by 3x plus 2 times it by x. Now it's up to you to decide which one is your gx, which one is your h of x. So I'm going to call this function gx, and I'm going to call this h of x. Now, next thing you need to do is write the function gx, which is this, 3x plus 2, and then write the function hx, which is x. Now we find the derivative of this. So derivative g prime of x will be, if we want to think about the power rule, we can apply, or we can just think about y equals to mx plus b. This is the derivative. So the derivative of this function is positive 3. Now the derivative of this one, h prime of x, will then be, if we're applying the power rule, we know it has a powers of 1, so we'd multiply it by power 1, multiply it by x, and raise it to the powers of 1 minus 1. We know that 1 minus 1 is 0, so we would have x to the powers of 0, and x to the powers of 0 is nothing but 1, so this whole thing will be 1. So we have 1 times it by 1, which is 1. That's the derivative of the function h of x. Now we go up here and then we find the derivative of f of x. We need to find g prime of x, and g prime of x is this, which is positive 3, times that by h of x. H of x is this, which is x, plus h prime of x. This is h prime of x, which is 1, times it by g of x. G of x is this, 3x plus 2. Now we can simplify this down. So if we do, so it's going to be 3x plus, if we distribute 1, we would get 3x plus 2. And then we combine the like terms, 6x plus 2. This is the derivative function f prime of x of this.